So my roundtable today will be about asynchronous execution in JavaScript. It's going to be very technical. If you're not technical people, feel free to leave. It's not going to be probably very interesting for you. Get here. And it's going to be a detailed walkthrough on different ways to execute asynchronous code in JavaScript. At the end, we'll see some results from the survey that I sent yesterday. We have some surprises. Okay, so when I thought about how to approach this issue, I tried to remember what was my first experience with executing non-trivial asynchronous code in JavaScript. And that question took me back to my previous job. And in my previous job, I was developing a web application for editing video files, more or less. If you have problems with the design, talk to your tutor. Probably his fault. And what you can see here is this is like a work area where you can play around with your videos. And this section is where you drag files from your computer, so you can play around with them later. So what happens if I drag a normal video file to the browser is that it goes through a process of steps in order to make it usable. The first step, which is done, is extracting metadata about the file. Metadata for video is something like the duration, the format, the width and the height. And this is done on the client side in the browser. And in order to keep the browser responsive, it's done in a web worker, which is more or less something like threads in JavaScript. So it's done in the background, and the result is sent in an asynchronous way. So this is metadata extraction. The second step, as you could see, is uploading the video to a server. And the third step is encoding the video into a format which this web application can work with. So 3 different steps, I'll write them down here. First one is metadata. Put it in green. Second one is uploading in red. And last one is encoding blue. This is done on the server side. Uploading is the bridge between the client and the server side. And extracting metadata is done client side, but in a web worker. And what is not so trivial about this example is that each and one of these steps can break. And the user should get an informative message telling him that something went wrong. So to demonstrate that, I have here a file which is, the extension is MP4, but it's not really a video, it's my ID. Okay? I'm tricking the browser to think that this is a video, and where do you expect this to break? Yeah, exactly. So it will attempt to extract metadata on a video file, which is not a video file, and this should trigger an error to the user. Let's see if it works. Yeah, so the upload failed because the file seems to be corrupted. Nice. So let's jump into the system code. Let's describe the first step of extracting the metadata. And the first approach is using callbacks. And when you use callbacks, the most common pattern is to give the input to a function, extract metadata, will get a reference to a local file, and you give it a second argument, which is a callback, which is a callback to be invoked when the output is ready. So let's skim through the code of this function. I said that this will initiate a walk in some web worker, so this is just don't dive into this, but this is like how you would initiate a walk in a web worker, and you would register a callback to continue when it's done. And when the callback is invoked, you will probably sanitize the output, make sure that it's indeed valid metadata, and if it's valid, if everything is okay, the pattern is to invoke the callback with the first argument as null and the second argument as a result. This is happy flow, and the set flow is to invoke the callback with the first parameter as an error and the second parameter as null. Have you seen this example previously? Probably in some node.js code. And let's think about what would this process, the entire pipeline of 3 functions, would look in JavaScript. So with serial flow, let's call this function process video. We'll get a reference to the local file, and we'll get a callback to call it when the entire process is completed. And it will call a series of functions serially, meaning it will call extract metadata, and when that is done, it will invoke this function callback, and then it will invoke the upload function, and then when that's done, it will initiate the encoding in the server side, and when that's done, it will call a callback. Happy flow, all good. What's missing here? Any ideas?
Error handling?
Yeah, exactly. So what about error handling? So I would say that the level of error handling with this code is something around like this. It works, but like if something small moves, then everything collapses. And there's no way to inform the user with something nice. So let's give it a second try. This code with, again, same code with error handling. Each time a function returns, we should check if it has an error and invoke the original callback with the error. 3 times, correct, and if everything is okay, then we call the callback. And what is the problem with this is readability. This is not really readable code. This is like what I look like when I look at this code in pull requests. So what can we do? Promises say the claim to solve some of these issues that we've seen here. Let's for a second look at the whole video. Let's look at what Ruby code looks like for similar tasks. A process video function will assume a happy flow, right? It will execute a bunch of functions serially, and it will register a catch clause, a rescue, in case anything bad happens. So this is convenient. We don't need to check for each step whether it succeeded or not. Another thing which is nice about this is that reading these lines is very natural. Like we all learn in math classes at a really young age to look at functions this way. The output is a function of the input. And in asynchronous callback style JavaScript, this is really not the case. So for me, looking at this code makes everything pretty readable. Happy flow ends with a return statement, and if anything bad happens, then we catch and propagate the error of that. So let's naively try to use try-catch in JavaScript. Try-catch work in JavaScript. That's perfectly fine to use try and catch in JavaScript. So what I did here naively is wrap the series of asynchronous invocations with a try-catch block. And this naive attempt will miserably fail. And the reason this would fail is that the execution model of JavaScript is very different than the one in Ruby. Let's imagine what happens in Ruby code. So let's, for a second, wrap this pipeline with the process video function, the one that initiates the entire pipeline. And at the bottom, I'm going to draw the call stack for this process. So in Ruby, in the example that we've seen before, process video is put on the stack, and it registers a rescue clause, a catch. And then it invokes the next function, and it's pushed on top of the stack, right? This is synchronous execution. And this is extracting metadata. And the way catch and try and catch works is that if there's any error up in the stack, then the frames of the stack are popped one after another, and we search for somebody to catch the error. In this way in Ruby, this would pop, and the catch would catch this, and everything will work. And on the other side, what happens in JavaScript is that process video is put on the stack, and this code initiates some work with extracting metadata. It does indeed put metadata on the stack, but this function returns immediately. It only registers a callback to be executed once the metadata has been extracted, once the web worker has finished his work. So this is popped from the stack. Actually, this is also popped from the stack. And the stack remains empty. What I mean by empty is that the node.js event, the JavaScript event loop will poll for events, and when extraction of metadata will be completed, only then it will invoke this function. And this is way too late. The try catch block was already popped from the stack. Questions about? All right. So promises. Promises claim to solve some of the pains of error handling and code readability. But I have a feeling, and this is part of what I tried to illustrate in yesterday's quiz, that promises are not fully understood by us. I think that the API is not natural, and I think it sometimes may lead to bugs. So I want to take a closer look at how promises work. And we'll do that by demonstrating three rules of how promises work. So I guess the most trivial use case of promises is as a mechanism to notify when things are completed. So it's kind of pops up implementation. And in this example, a fetch call will return the promise, and a then clause will register to callbacks. The first callback is the happy flow, the callback to invoke when execution was okay, and the second callback is start to execute in case that there's an error. For this brown bag, I want you all to forget that you've ever seen anything like a catch function. The reason is that the promise spec only specifies how the then method should work. The catch method is purely syntactic sugar. And the way that the reason that the promise spec only specifies the then method is to allow multiple implementations to conform without having to check whether the implementation is complete. What I mean by that is that, actually I'll try to explain it. So I guess you've all tried stuff like this before. You've all called some request method and registered two callbacks for success and error. This is pretty trivial, I guess, and without surprises, the quiz demonstrated that. Everybody understands this. The second use case of promises is a bit more tricky. The second rule of how promises work. And I call this the transform mechanism. This is nothing official, it's just names that I've given you, trying to make things easier. And let's take a look at this example. A promise, a fetch call is made with a then method on it, and we save that variable into something that I call promise2. And this little fact about promises is, I guess for beginners, is something that is not trivial. But the then method returns promise. It returns a different promise than the one that the fetch method returns. So the way this looks, if we try to illustrate it, the memory picture on the board is that calling fetch returns a promise, and this has the then method, and the then method accepts two arguments, right? It accepts the success callback and the failure callback. And what happens with this second promise, this is a reference that is returned from this function, promise2. So if the success and then returns some value, then promise2 is guaranteed to be resolved with that value. This is a mechanism to transform the resolved value of the first promise. In this case, we're parsing a response from the network as a JSON object and returning that object. The return statement here is really important because without it, the return value, the resolved value of promise2 would be nothing. It would be null or undefined in this example. And the same is true for the error callback. If you register a second callback here and return some value, then this promise would take the form of the first promise. It will follow it, meaning if this is resolved, then this would be resolved, promise2 would be resolved with the transformed value. Another thing that we get here is a better way to handle errors. In case there's any errors with parsing that JSON, who would you guess would be invoked? Like, would the set callback be invoked? The answer is no. This was one of the questions in the quiz. The answer is that promise2 will be rejected, meaning anyone who would register a then on the second promise, it will get the error callback invoked. Let's continue. The third rule for promises is something that I think is the most tricky part of understanding how it works. And in this scenario, in case any of the callbacks invoked here, the happy and the sad one, if they return the promise themselves, then the resolution procedure of the second promise here, which is promise2, is going to be delegated into another promise. In this example, it's loop. Promise2 is created by calling fetch and then, and only when it's invoked, the return value of that function is another promise. And what happens with promises is that we delegate the resolution procedure of promise2 into another promise. Meaning we follow, we say, we don't know, this is what the emoji tried to illustrate, and we delegate this to the second fetch call. So promise2 says, I don't know how to be resolved or rejected, I depend on another promise to tell me how to do it. And this mechanism is very effective in achieving chains of synchronous code. Questions? All right. So let's refactor, right? Let's think about the process video function that we've seen before with the 3 steps of extracting metadata, uploading, encoding, and doing all that while handling errors. So if I follow the example that I demonstrated now, in every then call, if I return promise, assuming all these functions that are promise, then effectively I've created a chain of promises that will only be resolved once the deepmost asynchronous function has been invoked. I can register an error callback on the entire chain. This is what I'm doing in line 5. So this callback, because the way chains work, if the original promise is rejected, then this reject handler would be invoked, and if this does not return anything special, then promise 2 would be rejected. Kind of confusing, I guess. And although we've solved some of the things of error handling, now we're only registering a single error handler. Some may argue, and I think they will be right, that this is still not very readable. This is not really close to the Holy Grail example that we've seen from Ruby. Yeah.
I didn't understand why, if let's say, generate extract metadata and it fails, why would the third then be triggered and not the first one? Because of the verb of the signature?
I'll try to illustrate the structure that we're seeing here.
If you were using the synthetic sugar, then basic sugar might make more sense.
We'll get it. Okay. So this is the promise returned by selecting metadata. And it generates a chain of promises by 3 then calls. And if it fails, then the first link in the chain does not register any error handles. You see that the second argument to then is undefined. So it will skip any fancy stuff and will reject the promise returned by this link. And this would cause this link to reject as well. Because none of the links here register an error callbacks except for the last one, then they will all pass the rejection signal, and it will reach the last one which does register an error callback, and this will cause the entire chain to reject. Alright. So the argument against this is this: it's still not very readable. It's better, but we're still struggling. This is a different picture than the first one. I don't know. She's slightly happier. Sorry. This is the before. Now she's happier. So we would like to get closer to the Holy Grail example that we've seen from Ruby, and for that we are in need for some syntactic sugar. And the mechanism for providing syntactic sugar on top of promises is called async await. So let's look at an example of the same code with async await. I'll try to explain what the sugar provides here. So declaring a function as an async function process video, what this means is that this function returns a promise. Okay, this will be in some implementations of code that needs transpilation. This would actually generate a new promise, and in environments that support this natively, this is like hidden from the eye, right? So this tells that this function returns a promise.
So process video returns a promise. It doesn't return the actual URL itself at the end?
No, it returns a promise. Okay. Now, every time you see an await statement, the way I think about it, and I think it's the correct mental model to think about it, is that this is like registering a then call on a promise. So metadata equals await extract metadata is the same as invoking extract metadata, which is a function that returns a promise, providing it with the local file input, registering a success callback for the metadata, and all the lines that appear here are the lines that would naturally go into the success callback here. Questions on this?
Yeah, about what he asked.
Yeah.
It will return a promise only if in code will return a promise.
Sorry?
What did you say? He asked
Okay.
if process video returns a promise, right?
Yeah. So the way this works is that this would indeed return a promise. If I would type this into a console and call this function, the return value of this would be a promise. I guess what we all used to see is awaiting on a promise. And if you call await on a promise, then the whole procedure of registering a then method with a success callback is hidden from us. So if I call this function and type .then, this would be perfectly fine. This would work. If I, on the other hand, call await process video, this would also be fine because of the fact that async await is just syntactic sugar above promises. All right? This translation is what we're usually doing. We're awaiting on a function which behind the scenes is registering success callback on that promise.
Also registers the error, right?
In this example, when we do a catch section, this is analogous to registering an error handler to the promise.
But isn't the wait catching the error and throwing?
Sorry?
I'm asking how does if it's like then,
Yeah.
so where is the
What would be the compiled version of the error handling? I don't have the answer for this specific case because it's a bit complex because we're saying a chain of a few functions, but you will see a then with a catch, like a fail callback somewhere in the process. Yeah.
I'm not sure I understand the async keyword completely.
All right.
Let's say I create an async function and I mark it as async,
Mhm.
then all I do inside is return a string. That's it.
Mhm.
Will this function return a promise?
Yes, it will return a promise, and that promise will be resolved to that string. So the way promises work, I didn't mention it, but you can register a then to a promise that has already been resolved or rejected. You would still get the value. So in your example, the promise is pre-resolved to a string, and anybody accepting that promise can get the string by registering a then. Any more questions on this? All right. So moving on to the fun part of the brown bag. I sent a quiz yesterday with some tricky questions, some more trivial, I guess. And the reason I did that is not to embarrass anybody, but except for maybe some specific people. But the reason I did it is because I think there is a claim that async await is a good abstraction, and you don't need to understand the underlying promises that they abstract. Yeah? Question? Okay. And what I try to illustrate with this quiz is that there are a few examples, a few cases, where this abstraction is leaky. You cannot safely use it without understanding what is the underlying mechanism. So to start, I asked how comfortable are you with JavaScript? Most of you answered that you feel pretty comfortable. We have some, not so much, and some experts. Yeah, so the numbers, okay, these are not 4 people. This is the average grade out of 5 questions that this group received. So the comfortable people answered 3 out of 5, which is the lowest score. Then we have some good representative from the not so much comfortable game answering 4 out of 5. And the people who said that they feel comfortable are indeed comfortable with JavaScript. They only got, these were 3 people, and they only got 1 mistake between all of them. So I guess let's look at some examples, and hopefully with the previous explanations we can understand what are the tricks, what are the pitfalls that we encounter. So what would be the output to the console? We're seeing a promise which is, by the way, in Bab, this is the mechanism to pre-resolve a promise. This is this statement would provide a promise which is already resolved,
I know that.
but we can still register the then callback. This was pretty trivial because the then method does not do anything special. Then the next then method would be called, and we'll see 1 and 2 to the console. This was good. Okay, this
Can I
is
ask a question?
yeah.
The catch here is the same as writing then with null resolution.
Exactly. I skipped that. Catch is syntactic trivial for calling then with the first argument as well. Here's a tricky example. I guess some people encountered similar stuff while writing async tests with jest, and this is more laboratory kind of example. What we're seeing here is an async function foo, which awaits a promise. Add is something that adds 1 with a promise, and it will then initiate an array and run for each on it. For each, we'll get an async function as well, and we'll await the num. And when this is done, we'll output the number 4. And we have 43% of people who got this wrong, and I do not blame them. This is where I claim the abstraction is leaky. And I'll explain what leaks here. Looking from the outside, this may look like a way to force JavaScript to be synchronous, force JavaScript to be Ruby. This is very readable, and naively reading this, I would assume that this section would block until all these inner functions have been completed, and only then we will continue to the next section. But let's imagine the promises that underlie this mechanism. What a for each function does is it iterates on the array and invokes a function for each and one of them. And that's it. And in this example, it will indeed invoke a function, and that function will indeed return a promise, but there's no reason for each function to wait for that promise. We didn't write anything explicit here to instruct this loop to wait on the promises resolved by the inner functions. So this is executed immediately, generating a bunch of promises. Nobody is listening for these promises. Then we call the console log with 4, and this function is resolved. This promise is resolved. By the way, every time you see an async function without a return statement, this means that this function resolved to undefined. It's successfully resolved to undefined. So this code will be executed. It will be executed long after or shortly after this function has finished. Yeah.
How would I rewrite it to get the 2, 3, 3, 4 result?
You would have to call something like promise all or promise map, which is a utility that runs a function on an array but awaits the resolution of the promise before it actually aggregates one big promise that you would have to await. Like you would have to await promise.all and then invoke. Yeah.
So something I don't understand, when you create 2 promises,
Mhm.
they immediately run, and the code inside every promise is blocking. So why would the execution continue to the last console log?
Again, I didn't understand.
When you create a promise,
Yeah.
the logic inside the promise runs immediately.
Yeah.
So and it's blocking.
No,
Why not?
because the trivial example is to initiate a network request.
That's a different thing. That's because the actual action is a promise itself.
Yeah.
What happens if I do like million times loop of MD5, which is
You're asking why this example, which is, it looks like this is resolving synchronously, right?
what makes it async by nature?
The stack of promises determines that no matter how you resolve the promise, it should not be resolved on the current execution stack.
So the resolve is run by using process nesting.
Exactly. Or something similar. Anybody else on this issue?
If we put it inside a variable, and then
Inside of what? Sorry?
the variable,
Yeah.
and instead the console log 4, it will console log the variable. Will it wait for it?
If I put what in a variable?
The console log in the for each. So instead you do for x equals await and none.
Wait on what? Sorry?
Add none.
On add none here inside the function?
Let x equals await and none.
It
And
wouldn't
then
make
you
any difference.
console log the x in await.
It wouldn't make any difference because nobody is awaiting on the return value of this.
But if you're
Inline
using the
function.
variable afterwards, is that
Still-
wait for it?
Still not.
So the problem is basically because we're using the for each.
Yes.
Like if we just didn't use the for each, we wouldn't have any problem.
If you would use a for loop here, it would work. Yeah.
Because
Because
if you awaited on the for each,
a for each would not aggregate the promises.
for each does not on promise,
For each does not return anything. Alright.
Just to push on that point, it's not the array for each that's causing the problem. It's the fact that the latter half of line 9,
Then what? Sorry?
it's, I guess it's indirectly the for each because you have to pass in a callback function. Never mind, that's wrong.
Let's look at another tricky example. A promise is resolved, and then we give it two callbacks. And the first callback initiates an error. It throws a new error. And like 44% again got this wrong because for various reasons, I'll explain what happens. When a promise is resolved, then creates a second promise, right? And what I tried to illustrate before is that this is the second promise. And this promise would be rejected in case that success callback initiates an error. But what we're doing here is we're providing two callbacks for the first promise. And the first promise resolved correctly. So there's no reason for the error callback to be invoked. This does not happen. This is invoked, which in turn causes this promise to reject. And if I would register and then null and error callback, this would be invoked. So the output here would be start, finish, the success console log will not be invoked because we have the throw statement before, so it will pause the execution, reject the second promise that is implicitly created here, and the error callback will not be invoked. Questions on this?
Yeah, who catches the error boom?
The what?
Who catches the error on line 5?
Currently no one.
So what is it? Goes into the ether?
So in the early days, this would do nothing. Now, in modern JavaScript execution environments, you would see a warning about an unhandled promise rejection. And in the next releases, probably of browser engines and Node, this would terminate the process. Browser probably not, but in next Node.js, this would terminate the Node.js process. This was rather trivial. I was disappointed that nobody answered Shawafel just for fun, but so we have a try and catch block with the async await, and we'll just see falafel and then Shawafel. Questions? Nothing special about this.
Everybody answered the question.
Sorry? We got 17 responses. This is, I guess, the most complicated example. And we got around 38% errors here. again, to remind you that this is the errors are not caused by the newbies, right? This is each and one of us that is confused by this APIs of promises. This is not our fault. I guess we're all experienced with JavaScript. I've been writing JavaScript for more than 5 years now, and I go to the promise spec every now and then to understand it because it's not very trivial. So what we're saying here, we have a bar function code, and we're registering callbacks with a chain. This is not the same as registering 2 callbacks for the then, like you asked about. This is creating a chain of 2 promises, and the first one will react to happy flow, and the second one will react to sad flow. And what bar does is delegate. We've seen that the delegate example. Bar delegates itself to foo, and foo resolves successfully. And then we have what I call the transform use case of promise. We get the result value. So sorry. First of all, we initiate an error in the happy flow here. The sort function is not a valid function on strings, and this would trigger the error callbacks on this catch method only because I didn't register it as a second argument here. This is another promise. But what this code accidentally does, it blocks the error and it swallows the error. It doesn't reflow anything. So what this will do is cause the promise returned by this then method to resolve. It will resolve with undefined. This is analogous to writing synchronous code, writing a try-catch block, catching an error, and doing nothing. All right. Okay, I think this is what we have. So to summarize what we've seen here in this roadmap, we've seen that callbacks are nice, but they have a problem of low readability when you try to write long chains and handle errors. We've seen that promises can ease some of the pain, but they still produce code which is hard to reason about. This is because of 2 reasons. The inversion of input and output that we've seen when calling a function. It's not that output equals f of input. And the second reason is that they still cause the code to be like a little bit spaghetti code. We've seen how promises work. I tried to demonstrate 3 principles of promises. One of them was pub/sub use case. The other one was a way to use promises to transform a value. And the third one was to demonstrate how to create a chain of async functions by delegating the resolution process to another promise. We've seen that async await is nothing magical. It's sugar above promises. And I try to claim that this abstraction is not perfect, and it may lead to writing bugs if you don't understand the underlying promises. Questions? Yeah?
I was reading a book that described all this stuff in terms of generators. Do people use generators?
I did not see any client code, like user code, that uses generators. I don't find them intuitive. The reality is that some of the transpilers, the Babel transpilers, transpiled async await using generators, but there's no need, you don't have to transpile
It's
with
an
generators.
implementation detail that does not.
Yeah, it's implementation detail. You can some transpilers purely transpile them to the promises. You can write any piece of async await code using promises. It will be more natural, I guess. More questions? Thank you.